everybody, and welcome to Best Practices for Dynamic Data Ingestion with Amazon S3 and AWS Lambda webinar. My name is Vyom Nagrani. I will be your presenter for today. Here we have with us Ajay Nair, who is a Senior Product Manager from AWS. Ajay will be our Q&A moderator today. A little background about myself. I'm a Senior Product Manager for the AWS Lambda team. AWS Lambda is a compute service that runs your code in response to events and automatically manages the compute resources for you. Lambda helps developers think about applications in a whole new way by creating simple event handlers or trigger responses. By creating event handlers that respond to updates from Amazon S3, DynamoDB, Kinesis, or SNS, and other services, as well as directly from web and mobile applications. I hold an MBA from the University of Michigan and have previous experience across product management, product marketing, and product engineering. Before we begin, I would like to walk the audience through a few items. On your screen, you can see a Q&A panel. Please submit your questions at any time during this webinar. Ajay will answer as many questions as time allows in the Q&A panel while I'm presenting. Also, towards the end of the webinar, there will be a live Q&A session, and I will address some of the questions as well. Lastly, this webinar is being recorded. We will share the recording and the presentation slides via email with all of the attendees after the webinar. So let's start off by a brief overview of what both of these services are. As all of you may be aware, Amazon S3 is a storage service for the internet. It's a simple storage service that offers software developers a highly scalable, highly reliable, low latency data storage at very low cost, and it's an object store, which means you don't need to manage any infrastructure around S3, or you can quickly upload objects directly to S3. But Amazon S3 has been long enough for folks to know what the service itself is. So let me talk a little bit more around which was something more recently announced, which is Amazon S3 notifications. S3 event notifications can be sent in response to actions in an S3 bucket, such as a put or a copy to a bucket. Amazon S3 event notifications enable you to trigger workflows, alerts, or other such actions in response to changes in your objects stored in S3. Some examples include transcoding media files when they're uploaded, processing data files when they become available, and synchronizing S3 objects with other data stores. Notification messages can be sent through Amazon Simple Notification Service, Amazon Simple Queue Service, or AWS Lambda. So let's talk a little bit about the benefits, or in other words, what's in it for you. The first is integration with other services. This creates a very easy way for developers to surface S3 as a building block for creating event-based computing. Since the notifications are sent by Amazon S3, you no longer have to do things like polling or have to continuously read the S3 bucket and keep doing a diff between the current version and the previous version. The second is speed. So typically a time to send a notification is less than a second, which means that you are able to very quickly scale up your applications and respond in near real time to S3 bucket changes. Whereas if you are setting up a poller, having to poll for the same bucket every second would probably slow down your workload as well as take a lot of resources. Here you're able to get the notifications directly sent to you in less than a second, which makes it very fast for applications to process this data. And then, as I mentioned, there's a lot of simplicity around this because all the proxies, the polling, the notification, all of this is taken away from the user, and you are able to directly have notifications sent to you rather than having to search for notifications. So moving to Lambda. AWS Lambda is a compute service that runs your code in response to events and automatically manages the compute resources for you, thus making it easy to build applications that respond quickly to new information. Lambda typically runs your code within milliseconds of receiving the event. The service automatically manages the compute capacity, it spins up the necessary infrastructure, it deploys your code, and it runs that code in response to each event that it receives. Which means that Lambda functions need to be stateless or have no affinity to the underlying infrastructure, and thus each event can be processed individually. This allows Lambda to rapidly launch thousands of copies of your function to run in parallel and can scale to the rate of incoming events with performance remaining consistent regardless of the frequency of events. Whether you're sending an event a second or you're sending 1,000 events a second, Lambda can quickly scale the same function by spinning up multiple copies because each individual copy is stateless. For example, you can trigger AWS Lambda functions to automatically create a thumbnail when an image is uploaded to Amazon S3. You can respond to notifications that are sent from Amazon SNS. You can verify address updates in an Amazon DynamoDB table, or you can even process clickstream data in Amazon Kinesis stream. Also, Lambda functions can be invoked directly from external sources, both synchronously and asynchronously, which makes it very easy to build a backend service to perform workloads such as image analysis, document transformation, indexing, and also simple things like a simple CRUD backend for mobile devices, mobile and IoT devices. So Lambda enables you to perform data-driven auditing and analysis on incoming streams, or you can watch patterns such as an address update, and all of these can trigger an alert in response to which Lambda can run. So the benefits of Lambda are that it allows users to focus on building powerful and dynamic applications in the cloud, while not distracting the productivity in undifferentiated heavy lifting of managing infrastructure. Since Lambda automatically runs your code on a high availability compute infrastructure, it performs all the administration of the underlying compute resources such as server and OS maintenance, capacity provisioning, automatic scaling, code and security patch deployment, monitoring, logging, AZ redundancy. So all of these are taken care of by the service. All you need to do is write the code. And an exciting announcement for those who missed this yesterday, Lambda now supports Java as a programming language in addition to Node.js. Another thing I'd like to point out is since Lambda runs your code only when needed, there is no unnecessary cost that you need to bear. With Lambda, you don't need to build out and maintain a fleet of servers and then pay for the time that those servers sit around waiting for jobs to run. Instead, Lambda charges a small fee per request, and it charges it only when the code actually runs, making it cost effective to build solutions that scale, as I said, from one request to thousands of requests per second. So the combination of Amazon S3 event notifications, which generate a trigger on data changes, and AWS Lambda, which provides you with the compute capacity to respond to such triggers and events, makes these two services a great fit to use together. We have talked about the image transformation use case for S3 and Lambda quite often. So I want to highlight that the transformation can be of any content types. It could be image thumbnailing or image processing that we have talked about. It could be transcoding audio or video clips, cutting or editing video films, etc. There are also many other possible use cases with which this combination unlocks, such as creating a data store on S3 with Lambda forming the front end, interacting with S3, and also with something like DynamoDB, which can make it a very good indexing service. You can also use this for processing any sort of data files or log files. For example, parsing of JSON files, converting from ASCII to binary or binary to ASCII, reading and filtering log files, aggregating data records, or even updating your data from Amazon S3 to a data warehouse solution like Amazon Redshift. Lastly, Amazon S3 also allows you to create object alerts which can be pushed to other services like Amazon SNS. But since AWS Lambda integrates with Amazon SNS too, you can receive a fan-out notification by subscribing to the Amazon SNS topic that S3 pushes to, and thus run multiple jobs based on these S3 object change alerts. And of course, the possibilities are limitless. We've had customers tell us various workloads that they have unlocked with Amazon S3 event notifications and AWS Lambda. We are looking forward to hearing your implementations, your suggestions, ideas, and questions around this use case. So let us walk through a workflow for a simple video transcoding application. So we start with the Amazon S3 bucket. Now, as I mentioned, when any video is uploaded to this Amazon S3 bucket, we can configure that bucket to send that event as a notification to AWS Lambda. Now, since Lambda receives this event, Lambda itself has the Amazon AWS SDK embedded into it. It can take custom actions. You have complete control over what code runs inside AWS Lambda. So you can program Lambda to respond to that trigger. So what we will do is we will do something like receive that event notification, transcode that video from one format to another, and then upload it back to another S3 bucket. So thus what you have a simple video application with zero infrastructure to manage. You upload videos to one bucket, Lambda runs in the backend for every video upload and automatically transcodes it, puts it in another S3 bucket. You have a live transcoder which you have set up in a matter of minutes with no infrastructure that you are managing. So let's start with the configuration and setup of this type of application. I will walk through the console experience of creating a Lambda function and associating it with an S3 event notification. So the first step of creating the Lambda is to create the Lambda function. So once you log into the AWS console and select AWS Lambda, if you select get started now, if you have no existing Lambda functions, or you select create a Lambda function, you will get to this screen. Here I name the function demo S3 video transcode. The name is a unique identifier of the Lambda function and becomes part of the ARN, or the Amazon resource name, of the function that you are using in case you want to address it using the CLI or APIs. I also added a description to remember what this function does. Now for creating the Lambda function, Lambda gives you three options. The first is to edit the code inline, which gives you a WYSIWYG type of editor, and you can directly start typing the code. You can also upload your code along with any additional dependencies, NPM packages, or even binaries in a zip file directly to the Lambda console. Alternatively, you can also upload the zip file to an Amazon S3 bucket and then provide the S3 object details as a source of your Lambda function, which allows you to integrate your custom deployment tools, which you might already have integrated with S3, to directly deploy Lambda functions. So one quick point to remember here is that my screenshot is from yesterday. As of 24 hours ago, you will get one additional option in this screen which is not showing up here, and that is to select your runtime with a choice between Node.js and Java. All of my examples are currently written in Node, but we welcome Java programmers to have at it and create similar examples. Now the Lambda console also provides code templates for different event types or triggers, including all the Amazon services that Lambda integrates with, as well as direct external invokes. So in this case, we will select the S3 get object template, and it will populate the sample code in the WYSIWYG editor, which you can then build on. So let's take a quick look at what that sample code looks like. As you can see here, rather than going through the full code, I'll just highlight a couple of things. All this code does is it calls S3 get object for the bucket name and the key name or the file name that it receives from the Amazon S3 event. So Amazon S3 sends the event which has some properties in it. The Lambda functions pull off those Lambda properties to actually get the full object that was published to S3. It then logs the content type of that S3 object to console.log. As you can see, the second last line is console.log content type. Console.log inside Lambda is directed to CloudWatch logs. So this is just a sample template. The next configuration to select on the Lambda console is the execution role for the Lambda function. An execution role is the permission to allow Lambda to take action on behalf of you by interacting with other AWS services. For example, the sample Lambda function here needs to read data from S3, as we saw it does a get object, and it needs to put data to CloudWatch logs. The Lambda console provides easy templates for creating basic execution roles, or you can even select an existing role if you have one. Here, let me walk through what it would look like to create a new S3 execution role. By selecting that, it automatically directs users to the IAM console on AWS with a pre-populated policy document. So this is the IAM console. Here you can change the name of the role if you wish, by let it be what it is. And you can expand or edit the policy document to add more options. Here's a quick look at the policy document. As you can see, this policy allows Lambda functions to do two things. One, it allows Lambda to make changes to CloudWatch logs on any log group, and it allows Lambda to get and put objects from S3. So when you click allow to this IAM console page, it automatically takes you back to the Lambda console with this policy created and attached to the Lambda function that you are creating. Now, I have made a couple of changes to this to give me more permissions than only a get object and put object. So I could do an s3.star to allow me to do more functionality here. So I said once you hit allow, it goes back to the Lambda console. Once you are there, if you hit create function, it will finalize the function that you are creating with this role attached to it and the sample code that we created earlier. From there, let us quickly jump to the S3 console and create, and I'll show you how to create S3 bucket notifications. So let's say I have a bucket called Nagranivi demo S3 transcode. So on the right panel under properties, S3 now has a tab called events. You can name your S3 event mapping to what you want it to be, and then S3 allows you to select which events you want to create notifications for. Currently, S3 can publish the following events: any new object created. So Amazon S3 supports multiple APIs to create objects, and you can request notifications when either a specific API is used. So you could do S3 object created put, or you could use a wildcard for any sort of object creation, which is an S3 object created star. And these notifications will be created when an object is created, regardless of whether the API is used. So even if you put something from a console or you do a direct upload, this event will be called. Another option is reduce redundancy storage object. So anytime Amazon S3 can send a notification when it detects that one of the objects of the RRS storage class has been lost. But in this example, I selected the S3 object created star, so it shows as object created all. Now I've been talking about events, so let me show you what an event really is. An event is basically a JSON file that S3 pushes to the selected endpoint. The JSON file has records which have fields like s3.bucket.name or s3.bucket.arn or s3.object.key, and these are the things which the receiver can use to take further actions, because the receiver now understands that this is the bucket and this is the object which has most recently changed. Now S3 supports 3 destinations where it can publish events to: an Amazon SNS topic, SQS queue, and a Lambda function that as we talked about. So when you select AWS Lambda in this radio topic, it will give you a drop down of all your existing Lambda functions. Here we can select the Lambda function that we just created, which is the demo S3 video transcode. Now S3 automatically adds the necessary permissions to invoke Lambda on your behalf. So there are 2 permissions here. One is for S3 to invoke Lambda, and then the other is for Lambda to do something with the event. So this creates the first one. So when you click save, this will save the object notification mapping. Now when any object is created or put to this S3 bucket, S3 pushes this above JSON as an event to AWS Lambda. Now Lambda at the other end is listening on your behalf for these incoming requests and will automatically execute that function code whenever it receives any event. So let's go back to the Lambda console. As you can see that the Lambda function we created now shows the S3 bucket as the event source. I uploaded one file to that S3 bucket, and the Lambda invocation metrics now show that one invocation took place, which took about 1000 milliseconds or one second to fully execute. So if you click on any of these logs that you see on the Lambda console, it will take you to the CloudWatch logs console. Now CloudWatch logs automatically creates a CloudWatch log group for you with the same name as your Lambda function, and that has the log history of all the functions invoked. Here you can see that the one function that I invoked is here in the logs. If you read the third last line, you will see that the content type that we had in the code is published here. The file uploaded was a JPEG file just as a test. So you will see here that this was a JPEG image. So as you saw, in just a few clicks, we created a Lambda function, we created sample code, we assigned necessary roles to it, we associated the function to an S3 bucket notification, we invoked Lambda in response to an S3 event, and we are able to see the complete execution and the final logs of the function. So from here, we'll go into our actual demo code instead of the sample code for transcoding files off of S3 instead of just logging the file type to CloudWatch logs. So again, instead of walking through each item of the code, what I'll do is a quick walkthrough of the things that I'd like to highlight. In here, I could include lots of packages or include a lot of NPM modules, which will allow me to extend my functionality to more than what is available directly. The first thing I do from there is set up some variables. As you can see, I'm going to publish the output to a different bucket, which is input bucket plus out. So my actual transcoded file will go to a different bucket, and I'm going to be transcoding files from an incoming video format to MP4. So I'm changing the output key or the file name of the output. The next thing I do is async.waterfall. What this does is it allows me to take asynchronous functions and put them in series where each function passes the result to the next function in the step. So this quickly allows me to create a waterfall type of workflow for an asynchronous code like node.js. So inside that, what I do is I just get the file from S3 from the event that I received, which means I upload something to the original bucket, it generates an event, I get the file into this Lambda function, I write that file to disk, because what I plan to do here is instead of an in-memory transcode, I'm going to be doing a disk-based transcode. Lambda allocates disk in proportion to the size of your Lambda function. And the fun part here is that you are able to include binaries in the zip file that you upload to Lambda. So I have included the ffmpeg binary, which allows me to do something special inside a Lambda function using the exec command, which spins off a separate process or a separate task inside of Lambda. So I do that ffmpeg as a / and then pass the file that I just wrote to disk. Since I give an output video, it transcodes that file and puts that file in the output video handler. So now that I'm back inside the Lambda function, after being executed as a separate spin-off process, back in the Lambda function, I read back from that disk and then upload that buffer to S3. So what effectively happens is, through this process in the Lambda function, I wrote to disk, had a different binary execute something on my behalf, and then read off of the output of that binary, which easily gives me a way of integrating different things which Node itself or even Java itself does not inherently support, because now you could have arbitrary binaries which you have in here, or you could include arbitrary packages which do a lot of functionality on your behalf. So from here, we'll quickly switch over to what the final output of that would be. So I have created the S3 buckets, I have created all of this. So what I will show you is in the S3 console, I have this bucket called S3 transcode. This has no objects in it right now. I have another bucket called S3 demo S3 transcode out, which is empty as well. So in this original bucket, I will upload a file in here, something that is not an MP4 format. So I have an AVI file which I plan to include. So I upload a file called flame.avi. When I start this upload, what will happen is that once this upload is completed, oh come on. Okay, it wants me to sign in again. So that is what I shall do. So when I go to this bucket and I upload a file in here, when this upload is completed, an event is automatically triggered, is automatically sent to the Lambda function that we created as a demo S3 video transcode. What that Lambda function would do, it would take this flame.avi object, it would get this file, download it to the Lambda function, transcode it, and put it to this bucket. So in here, what you will see is that you got the flame.mp4. So what this whole process did is automatically, without having to manage any infrastructure in near real time, it transcoded from the demo S3 transcode a file from the AVI to MP4 format and uploaded it to the transcode out bucket. And the benefit of this is you could do this at any scale. Instead of having to do this serially, you could literally upload 1,000 videos together, and Lambda would go off and kick off those one workflow each for each video being uploaded and publish that to the transcode out bucket. So moving back to the deck. So we saw how easy it was to do a live video transcoding with Amazon S3 and AWS Lambda, but this was a very basic, naive demo application. Let me talk about a few potential further additions you could do to a production video transcoding application. So in here, as you saw, I used FFmpeg binary, which means I can do things which are more open source for video transcoding. But you could include a binary which you have in your environment for custom transcoding, custom watermarking. And I said these are only, this is a video transcoding application, but think of any media transformation application. You could do custom image processing, you could do custom watermarking, custom face recognition, you could do audio extraction, audio manipulation, you could do enhancements of video that you want, you could do testing based on the video libraries that you upload. Second one that I'd like to call out is what you could do is you could break large video files into smaller clips, which means the first Lambda function that would be triggered would simply take the video clip and break it into smaller segments. Instead of transcoding it, it would keep the same format. And then for each of those transcoded clips, you could actually spin off another Lambda function which transcodes those individual clips into a different format. And then finally, all you need to do is join all of those formats. So this gives you a very easy way of, without having to manage infrastructure, to transcode large video files in near real time with your custom binaries, with your custom algorithms, with using S3 and Lambda. And the final one that I'd like to call out would be to transcode multiple formats by running multiple Lambda functions in parallel. Now an S3 notification can go only to one endpoint. So what you could do is send the S3 event notification to an SNS topic. But now SNS can do a fan out, and you could subscribe multiple Lambda functions to the same SNS topic. So you could have one function, one Lambda function which does AVI to MP4, you could have another one which does AVI to WMV, you could have a third one that does AVI to extract only the audio and put an MP3, and that gives you a very easy way of doing a effective all-to-all in real time for this video transcoding application. So again, these two are only examples of how you could extend the functionality, but I'm just trying to get at what are the different types of things that you could do now that you have this much of control on the binary that you're running and being able to do all of this without managing infrastructure. So let's move on to a second quick workflow. I'd like to call out how you could monitor and automate your infrastructure or your infrastructure policies or your compliance using S3 and Lambda. So AWS has a service called AWS CloudTrail, which logs all of your API activity on AWS Lambda, uh, API activity on AWS, and then pushes that activity to an S3 bucket periodically. So what would happen is, as and when there's different activity on your cloud on your account, that would get pushed to Amazon S3. And now we know that since Amazon S3, the moment something gets pushed to Amazon S3, you can have a notification that goes out to Lambda. So Lambda could then internally read back from that S3 bucket, get the log trails, and then you could do different topics based on that. You could either go into Amazon SNS and send a custom notification based on specific API activity. So you could filter out and say, anytime I have an activity X, I want to be alerted because this is something which my users are not supposed to be doing. Or you could even automate this whole process and go directly into IAM and block that activity from happening again by revoking those permissions or by setting tighter security rules. Now these are optional, but what I'm calling out is, once you have something inside of Lambda in an automated way, from there it's your code. You can decide what you want to do based on that. So let me do a quick walkthrough of what the code would be for infrastructure monitoring. Again, rather than going into the details, what I'll do is a quick highlight. I get the file from S3. Remember, this is the file which is coming in from CloudTrail. The CloudTrail is zipped and it's in a JSON format, so I first have to unzip it, and then I have to parse it using a JSON.parse. But that gives me a decoded data buffer. So what I could do is, inside this buffer would hold a bunch of events that CloudTrail has logged. So I could check activity for each of those decoded data entries, for each record inside the decoded data, and try to figure out what I'm looking for. For example, what I do in here is I'm trying to find patterns. So if the decoded data entry has a name called console login, and the event source is called signin.amazonaws.com, then I want to call that as a match, which means I'm trying to filter out any console logins. For example, I have advised my internal users that please don't use the console. We need to use SDK to be able to scale whatever we are doing. So we want to be notified anytime somebody logs into the console. So if you find that match, what you do is that you take some custom action based on it. So instead of doing the IAM rule, what here I'm doing is I'm only, as a demo, showing how to send an SNS notification in here. So I create a payload which tells me console sign-in detected from the IP address where it came in from and the time at which it came in from. So I could do a IP address and time matching to figure out this is the user which must have done this. And then finally, I just publish that to SNS. So let me show a quick walkthrough of how that would look like. So again, I go back to my S3 bucket. Here I have a bucket called CloudTrail, which I have integrated with the Lambda function that I showed you as a walkthrough. The bucket is currently empty. Now, if I set this as my CloudTrail bucket, it would take a few minutes for those events to go from sign in to actually publishing out here. So what I'll do is I'll take something off of my existing bucket and just publish it here to show what it would look like. This upload right now is a manual step, but in reality, it would just come in directly from CloudTrail without you having to do anything. So I already have one file in here, which is a CloudTrail activity log. As you can see, it's in a JSON in a zipped format. This is from a couple of days ago. So I'll just upload this and I'll show you how this is done. So once this is done, what I had done is send an SNS topic. So I should be getting an email if there is any activity that this function found in there which was not in line with my company policies. There might be a couple of minutes in delay in here as we have to wait for the email service to go through. So what would happen in here is Lambda pulls from S3, Lambda publishes that to an SNS topic, and the SNS sends out an email email blast. So it goes through a couple of steps here. So once you get this functionality in here, you should be able to see the email pop through. Okay, while we wait for the email, let me jump back, and once I see the email back in here, I'll pop back in here to show that the email has come through. So again, this is a simple activity which I showed in the demo. But here are potential further additions if you're trying to move this in production. So in addition to monitoring and alarming, you could create automated actions in response to these policy violations. As I said, you could do an IAM role, which you kind of make stricter policies. You could do some custom activity on your actual login page, where you could, for example, if you see a login from an IP address which you do not know, you could automatically go in and change your password. So you could rotate your credentials, you can rotate your keys. So those are types of things which you could do in here. Another one, if you want to make this more robust, is to create a .config file. So in Lambda, in addition to including npm packages and binaries, you can also include JSON files inside the code that you upload to Lambda. So inside that, you could create a .config file which has multiple checks. So you can have instead of just looking for one activity, you could look for multiple things inside the same Lambda function. And then each check could have a different SNS topic or a different action to take based on it. For example, you could do, if I see a login activity, then I want to send an SNS topic. But at the same time, if I see somebody deleting a S3 bucket or shutting down an EC2 instance or removing an ECS cluster, then you could do something different, and you could either go and create those back again, or you could stop those activities from happening further. And of course, you could also do something like you could aggregate CloudTrail log files to be delivered across different accounts into the same bucket. Now, CloudTrail doesn't need to publish to a bucket in your account, which means if you have multiple accounts for different parts of your stack that you are running on AWS, and you have one master account which is kind of your monitoring account, or which is your pair account which you are going to track all of activity in, you could have the CloudTrail activity from all of your functions, all of your accounts, go into the S3 bucket of one single account. So now you have to associate a Lambda function only in that one account, which gives you an easy way of managing this across having a single administrator bucket across all of AWS accounts. A third one I'd like to quickly walk through is a automated file deduplication. So as always, we start with a S3 bucket. Whenever something is uploaded to a S3 bucket, it goes to AWS Lambda. So now what AWS Lambda could do is it could read through all of the objects in the S3 bucket and check if the file which was uploaded last is truly a unique file, or is it just a duplicate copy of something else. And if it truly is a duplicate copy, you could take custom actions based on it. You could either go back to S3 and delete that object, or you could for example, you could associate this with an Amazon DynamoDB table, and where you have an indexing. So you could update the index to show that there are two files, when in reality you just have one file. Now again, these are all optional. What I'll be doing here is something similar. I'll just push this notification to SNS, and then we could have a look at this has been received, a duplicate has been detected, and you can take custom action based on that. So again, a quick walkthrough. So here what I'm going to be doing is slightly different. As you see, I'm going to be looking only at head objects. And everything else I used to do a get object. I used to get the full file. Amazon S3, in the head of the file, in the metadata of the file, has a flag called e tag. So the e tag is sort of a hash of the actual file. So instead of having to download the full file, you can get an MD5 equivalent hash of the head of the file. So this makes this processing much faster, because even if you're uploading megabytes or super large objects into S3, you don't need to pull the full object from S3 into Lambda. All you need is the metadata for that object, and you could quickly do something here. Similarly, I just list all other objects. I am not getting each object individually. list object will give me the metadata of each of the objects in that bucket. So in the same bucket, I have the metadata of the original file and I have the metadata of the other objects in that file. So what I do is that I start comparing e tags. So as you can see, what I'm doing is if my original e tag is the same as an e tag in of some other file in the bucket, but they are not the same file, because what will happen is when it does list object, it also lists the object that was recently uploaded. So at that point, I'd just break and say that this is a match. I found a match, and therefore I'm going to take an action based on that. And right now, the action I'm doing is I just send a notification saying that the uploaded file X already matches an existing file Y. So a quick walkthrough to how that would look like. So as you can see, I'm just going back to my email to see that the previous email that I had sent, a console sign-in detected, has now come through about 5 minutes ago. So it must have come through right after we switched over. It shows that email sign-in has been detected from this IP address at this time. So that is the log file which it kind of continuously shows. So in here, I have a bucket called de-duplication, which I have associated that Lambda function with. Now in this, I have a bunch of JPEG files. So what I'm going to do is I'm going to upload a different JPEG file, a file with a different name, but in reality is just one of these files. It just has been renamed. So what you should see is as I add file, I'm uploading mydesert.jpg. What this will do is that once this is uploaded, it sends a notification to Lambda. Lambda looks at the head object for this file, and then it compares this object with the rest of the object headers in the same bucket. And because it's going to find that my desert has the same e tag or the same hash as desert, it is going to send me a notification saying, you know what, I already found what you're going to what you have uploaded. Usually this might take a few minutes to come through as it goes through the Exchange servers. And we can come back to this too when the notification actually comes through. But what I want to highlight here is, again, this is just a simple demo. The way you could productionize this workload is to add a bit more functionality. For example, everybody knows of the e tag, because if it's close to MD5, will have collision risk. So what you could do is, instead of every time you have an e tag match, if you see an e tag, you actually pull both of those files, do a full SHA hash or do a full file hash, or a file compare, instead of directly notifying that this is a duplicate. Notifications are normally harmless. It's okay to get more notifications. But if you are doing something like a more detailed thing where you're going to delete the duplicate object, at that time you want to be sure that the object truly is a duplicate. And you could do this in a different Lambda function. So you could handle collision situations by calling another Lambda function to do the full compare, and you pass those two objects to the Lambda function instead of doing the full compare inside the same function. Now all of this gets super exciting when you create an index of all file names, hashes, and objects inside a DynamoDB table, which creates a file index for you now. So thus, as you grow your S3 bucket, you don't have to do a list objects and get all of the bucket items each time from S3. You could directly read this off of DynamoDB, which is going to be a much faster throughput for you. Plus, you don't have to hit your bucket each time. And now since S3 doesn't have a delete object API, the way you would handle delete situations is you could create a Lambda wrapper around delete object. Instead of calling delete directly, you call delete through a Lambda function. And that Lambda function, along with deleting the S3 object, would actually go and delete the index entry as well. So let's quickly go back, and as I can see, the email has come through, and it says the uploaded file mydesert matches existing file desert. So this is just one action which you can take, but there are lots of other custom actions which you could take from here. So a couple of things to remember about S3 notifications. One is that S3 notifications are at the bucket level, which means one bucket can be associated only with one Lambda function. There's a very high reliability for at least once delivery. We talked about the type of events that S3 object will take. And the configuration of this event notification is stored as an XML. And that notification sub-resource associated with the bucket can also be received when you do a get object or even a get head. And of course, there's no additional charge for S3 notifications. You only pay for the service which actually consumes the notifications. Quick points about how S3 and Lambda work together. So S3 scales automatically. There is no scaling limit to S3. But since S3 is pushing events to Lambda, Lambda puts all of these events in a queue and then executes off of that queue. And Lambda also scales automatically with the number of S3 requests that it keeps getting. Lambda has a default limit of 1,000 requests per second, but you can contact AWS Customer Center to get this limit increased. Which also means that in a matter of hours you can quickly scale up, and that too if you let us know in advance, then we can have that capacity waiting for you. Finally, since we have a queue between the S3 objects and the actual Lambda functions, you can have Lambda can handle a reasonable burst of super high throughput traffic, even though it is much higher than the 1000 TPS, because 1000 TPS is a Lambda execution limit and not a actual front-end limit. You could push many more events. We'll quickly queue those up, and for approximately 15-30 minutes, depending on how fast you're pushing them, we can hold on to those. Therefore, you can absorb bursts without actually having to increase your Lambda throughputs. A couple of best practices for creating Lambda functions. Lambda functions, the only parameter you need to mention is how much memory you want. And we automatically allocate CPU and disk proportional to the memory that you configure. So for CPU bound functions or for memory bound functions, increasing memory will often make your code execute faster. Now, since Lambda charges in terms of GB seconds, that is the time it took to execute times the memory you allocated, oftentimes we've seen that by increasing the memory, you don't have to pay more for Lambda because your code is executing faster. The second is timeouts. The increasing timeouts allow for longer functions to run, but that also means that if there's an error condition or a race condition, you have to wait longer for your function to go through. Lambda retries each function 3 times if it doesn't succeed the first time. So it tries each function 3 times before giving up and saying I can no longer process this object. By the way, events rejected by Lambda are often retried and retained by S3, and S3 will keep retrying for 24 hours for the same object, for the event notification to go through. For the permission model, we talked about how S3 pushes events to Lambda, and the console of these both take care of both, granting S3 the invocation permission through a resource policy and giving a Lambda execution role through the IAM credentials. Lastly, you can monitor and debug Lambda functions in near real time. Monitoring happens through CloudWatch metrics, which real time captures things like invocation count, duration, error count, throttle count, and it shows it for the last 24 hours of invocations inside the Lambda console. Or you could dump all of these to a CloudWatch logs, where all of these metrics, plus any custom logs that you push through, plus things like the RAM consumed per invocation, you could push through CloudWatch logs. Each function has its own log group, and each invocation in concurrent will have its own log stream. You can quickly search through log events, and we recently announced a functionality to push your CloudWatch logs into a Kinesis stream for real-time log monitoring applications that you may have. And we've had lots of customers who are running S3 plus Lambda in different workloads today. So we have companies like Comply or FireEye or Thomson Reuters, where the business use case for everybody is that they want to apply some custom logic to process content being uploaded to S3. So what we've often heard is that customers don't upload data to S3 for the sake of uploading data to S3. There's always some action which everybody wants to take based on the data that you upload. And Lambda very quickly fits into this in terms of thumbnailing or watermarking or any sort of media transformations. You could do file indexing and deduplication and file filtering, or you could even do things like log aggregation and filtering. You could do pre-processing if this is going to fit into a different stage in your pipeline, Or you could do things like content validation to make sure that the object is truly what you expect it to be, if you want to have some sort of validation over there. So with that, 3 quick next steps for everybody. We'd invite you to enable S3 notification feature on your existing S3 buckets. There is no additional charge, and you can quickly sync up event notifications to different endpoints, and you could take actions based on those endpoints. We invite you to create and test your first Lambda function. There's no new languages. We have Node.js and Java with more languages coming. No new tools, no frameworks to learn. All you have to do is bring your code, bring your binaries or your dependencies, and we'll do that for you. And of course, what we recommend is to start using AWS Lambda to process S3 objects. No infrastructure to manage. You could quickly set up a dynamic data ingestion pipeline in minutes. Thank you so much for listening. We shall take a quick 2-minute break here. I hope Ajay has answered most of the questions. I shall also take time to answer questions. I shall also take time to answer questions after the break. A quick call out though. We have a Chicago summit coming up on July 1 and a New York summit coming up on July 9th. And the AWS Lambda team is going to be presenting at both of these. So we really hope to see all of you at these summits. Thank you, and I'll be right back.